Good morning and welcome to our first paper session of the final day of CIDOC 2024. It's really nice to pick up off of some really great keynotes this morning, and it's a pleasure to be able to moderate this session, which I would characterize as looking at archaeological data sets, collection data sets, and methods related to semantic data and the use of AI. All of which are a few of my favorite things. Also, a few of my favorite speakers and some people I don't know yet, but which I'm excited to hear from, will be talking to you this afternoon, or this morning. And we are on a schedule, so I'm quickly going to give up the mic. I remind our speakers that there's a presentation of your presentation before you and the time, so I will wave at you if you're coming close to time, but otherwise follow the clock. Without further ado, I'd like to welcome the team presenting on True Integration, the Quest to Reuse Archaeological Documentation.
Right. Oh, alley up. Am I going first?
Yes.
All right, okay. Welcome to True Integration, yada, yada, yada. I'm Steve Stead. What we're going to talk about is using the CRM family to try and make archaeological documentation reusable, so the fair bit, the R in fair, and get things to play nicely. So to do that, we'll talk a little bit about CRM Archeo. We'll give an example and look at the tool support that we're developing in Sweden. And then I'm going to show you some examples of using it to represent digitization and cross-disciplinary support from a site in Ireland. And hopefully then we'll draw a conclusion. So there is no presentation complete without this picture of the core classes of the CRM. And I haven't seen one all week, so I was really glad that we put this in, because where would we be if everybody didn't know that we were event-centric, which I think might have been mentioned, and that we had physical things and conceptual things. So physical things you can smash windows with, conceptual things you have to put on something, some kind of carrier to smash a window with, although it can be you. So now that you've seen this diagram, you are now all carriers of the CRM, and consequently, if we need to erase it, we're going to have to hunt you all down and shoot you. Two of the things that we do with the CRM is that we enable ourselves to type anything, so we can add any number of classification systems to any object in the system. Classification systems are themselves conceptual objects, so we can have types of type, which is usually enough, and consequently we can discuss all of that. And appellations, we give names to stuff. That's not my usual phrase. I've been told to behave in my language by George. So we give names to stuff, and again, appellations are conceptual objects, so we can talk about them. We can have pet names for our names. We can have types of names. We can have names of types, and so on. There are a bunch of CRM extensions, and unfortunately, I forgot to put the animation in that replaces FRBR with LRMOO. So we're done without that. We're going to be concentrating on CRM Archeo at the bottom of the tree with a little bit of CRM Sci sat on top of it. So the big things with CRM Archeo is that it gives us the ability to start to talk about two different types of excavation process. The so-called spitting process, where you just take a slice out of the earth and draw whatever's there, which is very common to deal with cave sites and shell middens, and then the more English tradition of doing single context excavation, where we try and follow the things that have happened in the earth as individual events and remove the material that corresponds to that. Always we end up with lumps of earth, which we call stratigraphic volume units, and the interfaces between them. They can come in two flavors: a stratigraphic interface from stratigraphy interacting with each other, and then the ones that we generate by just digging a hole, which is an excavation interface. The process of actually removing earth is called excavation processing, so it's an excavation processing unit. And we also have the ability to talk about things which have got buried, or embedded, as we call it. So in this example, there's a coin that's being embedded. The key thing in the CRM Archeo is that we differentiate between the things we see and the meaning that we attach to them. So at the bottom of the diagram, you can see the stratigraphic units. So these are the lumps of earth or the interfaces. And they have physical relationships to each other, which we see in the field. And those physical relationships have a .1 type, which tells us what type of physical relationship there is. So is it above or alongside or below or whatever. Then at the top, we have what we assume is the way that the order of things that happen. So we have a series of stratigraphic genesis, that is the creation of the stratigraphic unit, the lump of earth or the interface. And we assume that they have some kind of stratigraphic relationship, that is a sequencing that we're interpreting from what we see in the earth. So the bottom of the diagram is what's visible, the top of the diagram is our interpretation of it. So we separate the two in CRM Archeo, which is relatively novel, and we point from the stratigraphic relationship, the sequencing, to the physical relationship to say this sequencing is based on this observation. So we're separating our interpretation from what was physically seen in the site. So this introduces a new type of relationship. So instead of the .1s, which come off a property and tell us the nature of the property, this is a justification between the stratigraphic relationship and the physical relationship. So here we've got a property-to-property relationship, which is relatively novel and absolutely impossible to do in RDF, because RDF is totally incapable of doing this. You have to fudge it. We hate that, so we've decided to move from RDF to something a little bit more useful, which is RDF star. So here's an example from the classic Harris matrix type process. So we've got a series of stratigraphic volume units of a combination of interfaces and lumps of earth, and then we have the physical relationships between those which are on the top of the set of relationships. I point. Can I point? Yes, here we go. So here we are, physical relationships to each other. And then the stratigraphic genesis, where we've built these things, or these things have occurred, which we now have a stratigraphics relationship, which is the storyline. And we're justifying from the physical relationship, the storyline, with these .2 relationships between the stratigraphic and the physical. Right, it's over to you, Joanna.
Yeah. My name is Jansen. I'm from the National Historical Museums in Sweden. I work at the department, the archaeologist, and I'm mainly concerned with the software we use. And I'm going to explain this example. So this is a layer of wood chips. It's called 2300. Make a note of that because I'm going to refer to 2300 a few times. We have several stakes driven through it. We have a layer also consisting of wood chips, partially covering the layer, and then we have the remains of a timber constructions that were found on layer 2300. So this, I know it's in Swedish, but so this is what it looks like in intricacies. You have all the attributes, you have the relations under, and belongs to, contains, and you have the long text, and you also have the graph view that can see how these objects are related to each other in the database. But what you can't see are the interfaces, because we treat the interfaces in a different way. They are attributes. So here you have an interface, upper interface, and a lower interface to the layer, and then there is a type that describes how that interface is. So we did a lot of mapping, trying to get all this in a structured way. And this is the drawing of that. So you have the volume units, you have the property that combines it with the genesis, you have the other properties that shows how they are connected to each other. You have a text down here that shows you what the properties are. We have just one example that we are also connecting to CRM Sci, which is that the layer 2300 was made on top of natural. It's called only natural. In Swedish, it's called the underground. And here we have taken in account also the interfaces that doesn't exist as object in the database, but they are described. And also the how we have connected them to types. The tools support we have is, so this is interest is behind the scene. And because the model looks like this, it's actually not that difficult to map it. When I have figured out all the definitions and the CRM, I just have to put that data in one table in one column. And we also already have a tool for entering data to multiple databases at once. And this is just an example of how that mapping may look. I'm not really sure if this is exactly where we're going to end up, but you have the A1 excavation processing unit, the P125 used object of type, and then you have E55 type. This is the this is how it was, what kind of tool the object was excavated with, because I mean sometimes we use machines, sometimes we use a trowel. So the E55 in this case would be the trowel. Back to you.
Oh, right. Okay. Thank you, John. So as you can see, we've started to implement the Archeo into the back end of the recording tool in the field. And if I'm now going to demonstrate the upshot of this using the results from some field work in Ireland from 2013. So this is the report of the excavation. And this is the daily log, the daily archive of the excavation. What I wanted to show to you here is how we take something like this, an analog text, and convert it into a digitized text, and show how we've done that as a set of metadata that's available in the database. So what we did is we typed it up using Mark I eyeball technique. So my wife typed it. And then we gave it back to Max, the director of the site, who'd written the original entries, and he annotated it. So he made corrections to things that Tina couldn't read of his handwriting, which was quite a few bits. And then he explained who people were that they knew, but you wouldn't know if you weren't part of the excavation. So Brian is only referred to as Brian in the original text, but he explains who they are. He mentions, the pub landlord from the local pub, all the things that you actually need to know. We were able to keep those out as separate elements so that we knew which things were from the original text and which things were annotations or corrections to that process. So we needed to record exactly how that had happened. So what we did is, using RDF star, we're able to talk about the diary entry for day 10 and its original writing, which was done by Max in the role of original author. So this is a .1 relationship that's actually coming off the relationship between the diary entry and the person who wrote it. This falls within a time span of when it was written, which falls within the declarative time span of Tuesday, the 3rd of September 2013. We have the excavation day, which also has its own time span, which falls within the 23rd of September, the 13th of September, 3rd of September, sorry. So we're differentiating between declarative and phenomenological time nice and clearly. We have a relationship between the diary entry and the excavation of the day, and this falls into the general 2013 season of the excavation, which is the excavation as a whole. Then we see the transcription, which was done by my wife, Christina, in the role of transcriber, which again has its phenomenological time span. And then we have Max, who edited and annotated that diary entry. So now we can see exactly how we got to that piece of digital documentation, and we can query who did what in the process of generating that piece of text, which is relatively novel. And we can see which roles that people had in each of those things by using the .1s. Alongside this, we started to look at how we could integrate the physical excavation that we'd been doing with oral histories about the area. So this is an account of the story about the monks processing from one of the monasteries to the other on the site. And the story is that the priest at the beginning, at the head of the process, of the procession, forgot his prayer book. So he said to the monk behind him, "Can you tell somebody to get my prayer book?" And this went back down the line of monks, and the guy at the tail end of it, the most junior monk, went and got his prayer book out of his chamber, passed it to the guy in front, and it was passed all the way forward till he had it in his hand before he got to the other monastery. So this is the legend, and it's probably a legend which says there were so many monks, we were so successful as a monastery, we had so many monks that this could happen. Right? But we need to tell that story in a way using linked data to make it available alongside the excavation records. So this is the process for doing that. So here is the procession of the forgotten prayer book, and we have its departure. The priest realizing he's forgotten his prayer book, he's asking for the book, the message being passed, the prayer book being collected, the prayer book being passed, and the prayer book being received by the priest before he arrived at the destination. And the two destinations are the places that we have the excavation records for. So we're now using those places as hooks to the real records of what we saw in the ground and the digital documentation of the process that we followed in order to get there. And then we have all the monks on the procession took part in it, the priest in the role of procession leader, and in another one I've got the prayer book itself as an object that we can play with. So this hopefully illustrates the fact that now we can move from one type of documentation into another. We can be truly cross-disciplinary by playing with the way we hook together different source types, different sources, to show a much wider and richer story than we've previously been able to do. And we can do it all in RDF star without having to fudge things by inserting false RDF nodes. Yeah. So, in conclusion then, CRM Archeo supports the splitting of evidence from interpretation. We're using that .2 mechanism. It allows us to have multiple interpretations, so you can put different sets of stratigraphic relationships in and relate them back if you reinterpret things. We're working on a site in Sweden at the moment where the carbon-14 dates came in 18 months later and redid all of the interpretation. So we're working on representing that in RDF star at the moment, and it allows us to do cross-disciplinary integration. So thank you very much.
Thank you very much for that excellent presentation on representing archaeological data and integrating it. I'd like to call on our next speaker, Mariana Curado Malta of the University of Porto, who will speak on archaeological findings, datasets and interoperability. Thank you.
Olá, bom dia. Gostava de saber aqui quem é que entende português, só para as pessoas terem a sensação que disto de estarmos a falar uma língua que não é deles. Ok, fixe, ainda somos bastantes. Okay, that was for you to have a feeling of what it is to listen to someone that speaks very fast and we don't understand half of it. It's a joke. I'm sorry, I took already 5 seconds, but it's okay because I don't think I will have the 20 minutes. I just want to ask, gostaria de pedir que me cantassem os parabéns uma vez que hoje faço 55 anos. I would like to ask you to happy birthday me, because it's my 55th anniversary. Okay. Okay, so now let's be serious. The next one had birthday yesterday, so this is really a panel. So I'm honored to be here on my birthday to present some work that me and João, we have been doing the last, I would say, 5 years. It's hard to work without financing, so, and unfortunately, we don't have many students interested in our work. I think everyone now all students are very focused on AI and all this technology, I work in a university, as you can see, Faculty of Engineering. I'm an engineer, I'm not an archaeologist. I'm very interested in cultural heritage, I always was, and I try to bring these students of informatics and information science, because we have a master in information science in our faculty, to work with me. João is in Lisbon, and he's an archaeologist, of course. I couldn't work without a specialist in the context. Actually, it was interesting to see the talk of that first talk we had in the morning about the smell, and our colleague was talking about the difficulty working between different contexts of knowledge, right? We engineers, I don't think I'm really an engineer, even if I did all my studies on that, meaning we have difficulties in putting ourselves in the contexts. Since I'm from information systems, I have to know how to do it. And that's always, even if it's part of my job, it's always a huge challenge, because we talk different languages. Even if we talk the same language, Portuguese, Spanish, French, English, whatever, Dutch, we don't have the same names. We use the same names for different things, and different names for the same things. Well, it's really hard, so we need to be aware of that, and that was the issue with João. It was difficult. And João was always saying, well, I said that, but maybe it's not like that. We archaeologists, we change minds every time, and I was like trying to understand what he meant by this characteristic, and then the next day it was different, and he had another, well, I don't want to say bad things about archaeologists, because I love them. Anyway, so today I'm going to talk about the work we have been doing. So it's a work in progress. So I hope you are kind to me, you, the archaeologists. João has been digging the site called Castanheiro do Vento in Foscoa. which is a place in it's north east Portugal, very near Spain. And he has been digging it for the last 25 years. And every summer he has these students coming from the UK and others, lots of coming from UK and other places in Europe. And actually it's UK funding that is having this, giving João the possibility of doing these findings. So he has he has boxes and boxes and boxes in a small, tiny museum in this Foscoa. It's not really Foscoa, it's near Foscoa. And I met João some years ago, and I said, look, we could work together and try to give some light to these boxes and try to put this in the semantic web. And he was like, what? So I had to explain all that, and he was very excited. So we started by the arrowheads. We have actually almost 100 arrowheads, but I know that it's not much because we have thousands and thousands and thousands of arrowheads all over Europe, which is interesting for the work we are doing, I think. And now we are starting with this thing, loom weight. I don't know if I'm saying well the word. And the axis, I'm always looking at the archaeologist there, the expert, that has white hair, so I'm sure he's very knowledgeable about these things. I am not. We started with this arrowhead, so we wanted to put it on the web of data. We wanted to publish data sets about these objects and the context. So nothing to do with what you have been talking about, I think. So you were talking about documentation and the things you take out of the earth, as far as I understood. Here is about really the objects and the context where they were found. And as far as I understand, we don't have really proper data models for that. So the idea was to provide a framework so that we can create these data sets about these objects. So blah, 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 I don't think this is important. So the technological or the information science context would be, I want to create a metadata application profile. This is a construct we have that was developed under the context of Dublin Core metadata initiative. Who knows about Dublin Core metadata initiative here? A lot. Great. Where is Antoine? Hi, Antoine. So the idea was to develop a metadata application for profile, and for that we need a domain model. Well, we need a lot of things, but let's put it simple in a way that it's really what matters here in this talk. So for now, I started with the arrowhead, a beautiful one here, right? Almost perfect, and actually, I want to say this personal experience of being there in the moment they find an arrowhead. I was very lucky. I was there, and there was a fuss on the site, and what? And there was an arrowhead in the hand of one of the archaeologists. It was so beautiful, the little arrowhead in the hand. So it was for me to be really in context, because I really wanted to feel that feeling, not only about. It's not about digital. We're talking about tangible things that exist for thousands of years, and it was really thrilling for me as an information architect. We started with the arrowhead. I didn't have any other idea that there were other objects. This was last 2 years ago or 2.5 years ago. João didn't talk me about anything else than the arrowheads. He was very, very enthusiastic about that. So I started doing a model about arrowheads. And then I was like, I don't know if an arrowhead has enough info to create a domain model, but let's go for it. So I started this, as the first talker said, I went and talked to him, and I came back, and it was like always go and come about Zoom meetings, because he is in Lisbon, I was in Porto, which is 300 kilometers away. We are not going to travel because of that. And then suddenly he said, oh, because the contexts and the you know, what I'm talking about, it's a difficult word. Can you tell me, please?
Stratigraphic unit.
Yeah, stratigraphic unit. Yeah. And I said, oh, it's important to talk about the context. Very important to talk about the context. If we have context, it's good that we give. So I start digging in the CIDOC CRM, and I saw that there was a CIDOC Archeo. Why do I want to use the CIDOC Archeo? Why do I have this idea of CIDOC? I think it's important to say to this community. Interoperability is a very important issue, as you all know, with datasets. With whom do I want to be interoperable? About arrowheads? I don't know, and João didn't know, but I studied that interoperability is important, and that we have to use vocabularies or ontologies, whatever you want to call them, metadata schemes, and control vocabularies that others also use. So at least we have levels of interoperability with contexts of the same knowledge base or context, and even other contexts, so we can open interoperability with other contexts. So I went to look for vocabularies that are from the cultural heritage world. Okay, so I saw the Archeo, and I said to myself, I have to use this. I mean, I have to use it. So as you see, the colored ones are the ones that are from the CIDOC world. So I decided. Then I understood that I had to find the characteristics on the object, the item arrowhead. But then there were other levels of knowledge that I wanted to extract. So the context was one of them, the archaeologist that was in charge of it. And then we can discuss, oh, maybe we can put metadata on the data set and not be in the model. Or we can also use RDF star, but it's still not really... well, we can discuss about that. I actually have a student that we are working on this type of RDF for meta information, right? Which is interesting. Anyway, so I have the model 1 that talks about the excavation and the location where the excavation is, and then connects to, so in the excavation we have contexts. To arrive here it was really hard for me because João was difficult. Okay, but I hope this is, yeah, so an excavation has many contexts. And I said to João, please, now you define all the contexts you have in Castanheiro do Vento. Oh, I don't have information about all the contexts, he said. I want you to create the data set, so I have an Excel file with that. The context that you know, not the ones that you don't know, but the ones you know, because the context, it's common to many items. At least I think it was what he said. Anyway, then we have module 2 that where we can define the contexts we have, every context with the levels, stratigraphic volume unit, and then we can define timelines, and then we have encounter events. But then some encounter events, they were in the past, so they don't have context for that. Some have contexts, others don't have contexts. So I decided to connect to excavation, not only to context, for instance, so that I could define an encounter event of an item without context. And then here is the model for the arrowhead. So in the beginning, I thought there was not too much to say about it, but there's a lot to say about a small arrowhead. As you see, some of arrowhead, it's E24, and then we have here units, so the base and body length. But of course, I knew that the CRM Archeo was not going to have properties and properties and classes for this. I mean, we have condition state, which is so. This was the beginning of my work. Then afterwards, João said, "Oh, well, we have this axis and these loom weights. Maybe we could start with that." So I decided that we are not going to have arrowhead as class, but item, of course. And then an item can be many things. Can be an arrowhead. I did this. I find it very pretty. So I decided that this is module 3, I'll have module 4, and I'll have module 5 for the different items that we have found. So we need to, this is working. We already have the axis properties all defined. So it's what we are doing now. So we'll need to go and continue our semantic web context work. Yeah, I like the figures, that's why. And I mean, for now, we already did some development in the informatics side. So it was all done by me because I couldn't find any student interested on this work, so it's okay. I'm happy to do it. The problem is time. We used all these vocabularies, so the CIDOC conceptual reference model, scientific observation model, archaeology CIDOC, but also other vocabularies because there was no possibility to use CIDOC for all of that. The rationale was, let's look for vocabularies that are used, most used. So for that I used I'm sorry, I forgot the name. Since I have this burnout, when I'm a little bit stressed, and in English, I'm not ashamed saying that I had a burnout last year, so it's okay. Now I'm feeling better, so it's okay. So we developed this application profile. We created an excavation metadata scheme for the properties we couldn't find anywhere. So I think it was a beautiful work done. And we metadata scheme, so for arrowhead. Also, for all these characteristics, they are so specific to that object. So this one, I think it's really a valuable work that we hope that others will use to describe arrowheads of that Paleolithic, Middle, Bronze, that I don't know how to say perfectly, but it's beautiful. So controlled vocabularies also for the characteristics of the arrowheads. We did it in English and Portuguese in SCOS, but we hope to enlarge, for instance, for Spanish, at least Spanish, French, I would say, if someone here wants to translate, or Dutch, Swedish. I love Swedish language, so if you want to contribute, just so everything is in GitHub, so you can, if you are interested, take a picture and you can go there. We have a small data set, and we don't have time for that. So 8 seconds. I leave you with my email, and I thank you for your patience.
Thank you so much, Mariana, for that very interesting talk and very nice continuity with the previous speakers. I'd like to invite to the floor Lucía Sánchez de Bustamante from the National Autonomous University of Mexico, UNAM, who will speak on university collaboration and challenges in the management of archaeological heritage. Thank you very much.
Thank you, George. And happy birthday, Mariana. Thank you. Well, good morning to everyone. And my name is Lucía, and I am responsible for the archaeological collections of the Universidad Nacional Autónoma de México, together with an excellent team of archaeologists. And I am also coordinator of Rijksmuseum Museum, both at the Centro Cultural Universitario Tlatelolco. I would like to take this opportunity to thank the organizers for this space and all the efforts of these days. And I would also like to thank the people who have presented their work for sharing projects, initiatives, challenges, and expectations. After listening to all of you, I take with me the reflection that beyond the particular situation of our countries, technological issues, and sometimes also specific aspects of politics and cultural policy, we are facing similar challenges, such as for what or for whom to publish collections, how to document or publish, how to make inclusive documentation, etc. But also with the common component of the passion for for cultural heritage and for providing solutions to these challenges. So thank you all very much. Well, addressing the issue of building knowledge networks and the particular topic of collaborative efforts, on behalf of my colleagues from Tlatelolco and Edurne Uriarte, he's there, I would like to briefly share with you what are we doing for the management and documentation of archaeological collection of the university. Although we have been in charge of part of the archaeological collection and custody of the university since 2011, the FUAPO, the collection, was consolidated until 2019 by instructions of the then rector of the university. Between the pandemic period, the inauguration of Xaltiloli as a new archaeological museum at Tlatelolco, and the preparation of the area to preserve and take care of the archaeological objects, intense years of work followed, but in June of this year, finally brought together the more than 15,000 archaeological objects that conform the archaeological collections of the university, that we call FUAPO, Fondo Universitario de Artes de los Pueblos Originarios. The name is over there. So, but for us, this was only one of many steps, because it is not only about the proper safeguarding, but also about the proper management and implementation of an information management system that allow us to propose a comprehensive and inclusive documentation. Therefore, our main challenges, as you can see, are as follows: documentary research and recovery of memory of collections without archaeological context, which are usually little recognized in our professional practice in Mexico. Development of a documentation system with the implementation of international standards for documentation applied to archaeology. digitalization of collections and publication as open data, at least initially, the integration in a documentation system oriented to CIDOC CRM, that is to say, that in the future it will allow us to create knowledge networks among the entities of the model we are already working on in the development of our socio-technical context, and the inclusion of administrative processes, which are also fundamental in the institutional life of the objects, in the documentation system as a part of institutional and bureaucratic aspects of life. Okay. With these challenges and a lot of passion for archaeology, everything began in Tlatelolco. And also we began to build the bridges of collaboration that we show today. Precisely, here you can see a brief account of the events of the conformation of the collections, the creation of the spaces, the management, the research, and the parallel life of challenges and collaborations. Mainly with Pedro Ángeles and the UNIARTE team, with the Museum of Contemporary Art of the university, and with the General Directorate of University Repositories throughout the work of Edurne Uriarte. So, there are some of the representative objects of the collections that we have. They're beautiful. In a way, the challenges I have shared with you have defined part of our functions at FUAPO. However, the people here present who work with collections know that the list of activities is endless and that we are always looking for that little bit more for the objects, spaces, and audiences we work with. Here, I would like to stop again to explain what strategy we are implementing. But first, I would like to point out that something that all of us in Mexico have in common is what we start from the importance of preserving the memory of cultural heritage, of the possibility of making it accessible to all those that want to know it, and always generating quality work. As you can see here, the collaboration network was established between 4 areas of the UNAM. The GAF, or Visual Arts General Directorate, as the area responsible for some administrative reason for the archaeological collection and its archive. UNIARTE, as the academic area that promotes the documentation of cultural heritage and implementations of standards in the university, and is responsible for the formation of new generations informed about the standardization and normalization. The GERU, the General Directorate of University Repositories, as the area of the university that is acting as an aggregator of all the university collection and systematizing the information with a view to its publication, and as CCUT, and as those responsible for the archaeological collection and generator of the challenges, may I say problems, of management and documentation of these objects. So, after several years of collaboration since 2019, we have all managed to coordinate our work and on these arduous processes of systematization of information, academic training, and discovery. Thanks to UNIARTE, courses have been carried out at postgraduate level for the implementation of standards, as well as workshops with George Bruseker this year, and training in platforms such as Tainacan and Omeka. But we also have moved from theory to practice. On November 21st, in a few days, we will publish the first official test of the collection. There will be only 200 objects, but we have already worked with more than 10,000, and they are ready to be published whenever our authorities let us do it. We are working in this moment with BRA, but we are thinking in working with a CRM model. So, anthropological and documentary research has also been carried out on the collections and objects, and little by little, the pages of the collections census are being brightened by the HERU, which will allow us to systematize people, events, and places, and add to the preservation of information and knowledge of the collections. Of course, we still have a lot of work to do, many things to learn, and many more to implement. But for us, to know standards was something relatively recent, and it is an even more complex challenge because archaeology in Mexico does not implement them. We are proud for our first results, but they are only, as always, the tip of the iceberg, of an integral management of cultural heritage that we want to implement. Our perspectives are to continue with the implementation of international documentation standards for our collections, make them public, and put them in value, but at the same time develop internal norms for the archaeological heritage and collections, improve administrative management, and integrate it to the documentation process, and begin with the implementation of CRM, from the generation of information and implementation on resources, probably patterns, that allow us to make visible the life history of our heritage. We consider that these collaborative networks generate knowledge, but they also generate effective networks and connect people, sometimes colleagues, visitors, or users, and also connect wills. These models schematize our representation of a world in which, although we do not necessarily know how to dialogue, how to make inclusive documentation, how to deal with technological limitations, or how to communicate with publics and communities, it is defined for us as a world in which we want everyone to be able to discover cultural treasures and life stories. Thank you very much.
Thank you very much, Lucía, for that excellent presentation on some really impressive work on some really beautiful heritage. So we're going to turn our attention now to another form of data set, specifically thinking about digitization processes of collections and remaining issues. Our presenter is Hosun from National Hangeul Museum. So please take it away.
Okay. Good morning. I'm Hosun, responsible for education and research at the National Hangeul Museum. It is truly an honor to have opportunity to present at this 2024 CIDOC conference, and I am learning a lot from the excellent presentations shared here. As this conference, a theme of a sustainable connection, I'd like to introduce Korean Museums Connected Platform, eMuseum. eMuseum is a collaborative project involving over 300 national, public, and private museums across Korea. NHM, established in 2014, focused on Hangeul. Hangeul means Korean writing system, and script-related materials we collect. And it is part of the Ministry of Culture, Sports and Tourism. The ministry oversees for National Museum with an additional 13 regional national museums. Here is an overview of NHM. Currently, we are expanding the building, so temporarily closed for 1 year. You can see the permanent and special exhibition hall. NHM collects material through purchases, donations, and transfers from other organizations. Our collection ranges from 15th century to contemporary item. And we go through classification, as you know, numbering, conservation treatment, photos, and metadata entry before they are officially registered. This is the login screen for the Cultural Heritage Standard Management System, which is the platform we use to register and search materials. Managed by the National Museum of Korea, the affiliate our ministry. Plus freely available to institutions that wish to use it. CHSMS, the upper menu, it's sorry, in it only Korean language. CHSMS, the upper menu includes options for search, statistics, management, public access, registration, and settings. On the left side, you can find my page and edit favorites. While on the right side, download manual about CHSMS and e-learning and a link to e-museum. The last. At the bottom, you will see information about newly registered materials and notice from manager. Collection search section and result. Users can also view not only the primary image, but also all available images for each item. CHSMS is stable and secure and enhanced institution autonomy with self-generated codes for their own collection, classification, and storage location, etc. Excel format conversion is available. The CHSMS, as you can see on the right side, can be utilized from the NMK website. This is a distribution procedure on the website. Now, let me introduce the e-museum. Since it was developed with funding from the ministry, all the budget support, and is operated by the NMK, so it uses a government domain. The website went public on December 1st, 2016, after a 1-month test run. NMK linked the CHSMS and e-museum, the two. The information stored in the CHSMS can be retrieved in an e-museum. Each museum can choose whether to make information and images of their collection open to the public, and even select the type of the Korean open government license. 2016, initially, institutions were hesitant to make their collection public outside of their own website. However, my ministry, with providing subsidies and incorporating open rates into evaluations, so the number is increased, has increased amazingly. Based on daily updated statistics, as of November 11, on Monday this week, e-museum has 367 participant institutions with over 2.6 million materials accessible, over 1.8 million downloads, and a total of over 3 million images served. This e-museum has several sections such as Museum of Today, Browse Collections, and Collections Quiz, which randomly display items from all collections featured in eMuseum. And there are also 4 main menus: search collections, nationwide collection overview, eMuseum story, curating my own exhibition. On the homepage, you will see the collection library, where you can search within specific categories: dry gelatin plate, holding institution, national treasures, nationalities, materials, provenance. Let me show you advanced search. Search filters are visible on the left, and the last box is option for a high resolution image only. Clicking on each catalog reveals a more detailed classification system. Clicking on the title or thumbnail images of the items can also be opened in a separate window. You will see an open over there, open mark, highlighted in blue, indicating that these materials fall under the first category of government-designated public works. Example, user can download the current image or the image entire set, or share the thought, share it with their personal account. And from image scrolling down below, you will find the details about the item's name, nationality, size, classification, material, and so on. On the right, show the relative terms and similar materials recommended, and as well as recommended exhibition. eMuseum uses adaptive web design that allowed it to provide optical view for mobile device. And moreover, eMuseum provides the open application programming interface through the public data portal for anyone to use. Yes, and the last page. There are several issues, I think. First, a few information are uncertain, and some images, I think, low resolution images that were quickly uploaded to increase public accessibility. Secondly, only 367 institutions indicated a relatively low engagement rate, because in Korea, approximately 12,000 museums registered. Third, furthermore, some institutions provide lower quantity or lower quality metadata, which can impact user satisfaction. Finally, there is the issue of preventing the misuse of open access materials. I hope this presentation has provided the connection platform for museum data in Korea. Thanks for listening.
Thank you for a very fascinating talk. I think that was a really interesting look at integration and aggregation, and I'm sure there'll be many questions either here or in the lunch. We'll move right on. Our next talk is called How AI Became Our Metadata Wizard, and it's presented by Bart and Magnus of the Meemoo and Flemish Institute for Archives. Thank you.
Thank you. I'm Bart indeed. I work at Meemoo, Flemish Institute for Archives, and in the next 10 minutes I will tell you a bit more on how we started using AI to create and enrich metadata. This is Meemoo, this is a team, and if you haven't found me by now, then you might be inclined to think that facial recognition technology might be useful technology to help to create metadata. What do we do? One of the things that we do is digitizing heritage content for more than 180 partners. We archive that content in our archive system. We make it accessible, we make it usable on different platforms, and we also share our expertise about digital heritage processes with other organizations in cultural media, government. So that's very briefly what we do. How did we start to using AI? We asked ourselves the question how AI could help us to create metadata and enrich metadata, because we have a lot of material of these 182 partners in our archive system, sometimes with poor metadata. So our approach there was really starting from practice, see how this could work technically, how we could scope this into project, how collaboration with partners could be organized, because it's a lot of partners, of course, that should be taken into account. And theoretically, there were the legal questions, the ethical questions that came on our way. Our approach was very carefully dipping a toe into the water, so rather like this than like trying to be a polar bear club. We started with the FAME project, where we focused on 3 pilots about performing artists, cyclists, and politicians and activists. We had 4 collections involved, and we had ID Lab from Ghent University as a technical partner. So we tried to focus on public figures, also to avoid too complex issues with privacy and so on. And we wanted to define in advance who we wanted to recognize. So we had to define what a public figure is, which is a huge problem in itself, of course. But basically, we wanted to get together a set of photos of persons X, Y, and Z via partners, via other cultural heritage institutions, sometimes semi-automatically via Wikidata API and so on, and also manually, which is very time-intensive. But you can see that we managed to get more than 50,000 portrait photos of more than 6,000 unique persons. How did that pipeline look like? Several phases. So first of all, there was the face detection phase, so where a model tried to get to know where a face is on a photograph. These faces were encoded into vectors. Similar vectors were clustered together so that people who were probably the same were also clustered together. Based on the reference set that we had, a prediction could be made who was depicted on the photograph. Then we moved on to human validation, and then finally there were the results. Now, this was a relatively small project, as you could see in the numbers. Now, the question also came to our minds how we could scale it up to 170,000 hours of video and audio material from all these partners. So watching all that material once takes one person 19 years, 24/7. So it gives you a little bit an idea. Yeah. So there was not only facial recognition, but also speech recognition, and from speech to text also to named entity recognition. And then the idea was to get out metadata that could be searched as linked open data. For speech to text and named entity recognition, it was quite clear that after setting our requirements that there was very good products on the market that could meet those requirements. For face recognition, it was a little bit more difficult, especially because of these ethical and privacy requirements. It was more difficult, and so we decided there to build instead of to buy. Some brief results. What you can see here is a screenshot of our validation tool, where you can see a page of a digitized video with people that were recognized in that video, how long they are in that video, and so on. So it's a digitized TV program of 1986. Generally, we could say that we have very detailed metadata, very high quality and quantity, and where possible, all these phases were also linked to Wikidata. The reference set management is something that is behind all this, of course. So we had a maximum of 10 reference photographs per person, also linked to Wikidata where possible. So where you can see that a certain person has reference set, links to Wikidata, and then below the videos in which this person is recognized. The domain expertise of archivists remains very important, and so the human in the loop is not only important in terms of validation, but also in terms of helping each other and putting names to sometimes clustered but unidentified faces. When an archivist puts a name to a face, it means that this person can also be recognized in other videos, not only within that same collection, but also across collections. So that it's really archivists helping each other. That's the idea. Yes, that were the missing arrows. That should have been clear from my explanation. All right. Speech recognition and named entity recognition, also there, very detailed metadata. Quality is a bit more, varies a bit more. Also there, concepts like geographic locations are directly linked to Wikidata. One of the remaining challenges that we had was this reference set. I already said is a very time-intensive thing to set up, and so we asked ourselves the question: what if we could work together on this? What if we could work together on a shared name list and a shared reference set? And we started a follow-up project for that, the Visual Name Authority. So it has nothing to do with the facial recognition itself, but only with the face before. So setting up that reference set. So it's a lot about technical processes, about how we organize that collaboration with different partners. And there's also legal and ethical questions. So it could look like something like this, like you have a name of a politician with some very basic metadata linked to existing sources, either from internal sources from archives and museums, either or Wikidata, ISNI, VIAF. There are the reference photos, and the idea is like, can we manage that together to have a good starting point to apply facial recognition? Also, the whole governance of that whole thing is really a thing. Like, how are we going to decide which partners can edit which things? How these processes have to be? It's really an open discussion right now with the involved partners. So we want to try that out and see what can happen. Okay, I have like 1 minute left, so and this is what I could have said a lot more about, the problematics of AI as terminology, especially in the contexts like these where you have very limited use of technology. I prefer terms like machine learning to AI because it's much more about algorithms, mathematics, computing power, than that it's about something that's, let's be honest, not so artificial, not so intelligent. I could have said a lot more about privacy and ethics, but I'm happy that yesterday afternoon this topic was already discovered a little bit. And there is a remaining challenge to get the data that comes out of such a pipeline back into the source systems, of course, which is a huge challenge at this point, and we look to knowledge graph-like solutions to try to do that. So that's a lot of challenges for follow-up projects, but I hope to have given you some impression of where we are and where it will lead us to. Thank you very much. Okay. 。 . 。 。 。 。 。 .
。 。 。 。 。 。 。 。 。 。 。 。 。 。 。 。 .
Okay. 。 . 。 。 . 。
。 . 。 . 。 . 。 。 . 。 。 . 。 。 . 。 。 . 。 。
Okay. One short thing, we did this together with my colleague Matthias Priem. Normally he would be here to do the presentation as well, but more technical questions can also go to him. I was more involved in the privacy ethics side, but so it's a joint effort of a lot of people. Thank you.
Thank you very much. So we will invite our final speaker, who is William Thorne from the University of Sheffield and the National Gallery London, who will speak on the topic From Linked Art to Text and Back Again, an Unsupervised Approach. Thank you.
Yes, thank you very much for having me. And sorry, slow, I'll speak slower for you. Only 10 minutes, of course. I'm not sure I can do both of those. So I'm halfway through my doctoral research with the University of Sheffield and the National Gallery, supervised by Rupert Shepherd, which I'm sure many know here, and Diana Maynard. And I'm going to be presenting my current work in progress. So everything in this presentation is subject to change if the need arises. But I will move on to the motivations. So within institutions, what we have is we have a fantastic collection of text. We have a fantastic collection of, in many institutions, linked data, but we have very little actual direct mapping from one to the other. And many different stakeholders need different access to data. So the public is not particularly linked data savvy in normal cases. But equally for research, linked data is far more valuable to be able to find connections and aggregations across our own collections and across various other collections. But this annotation process is incredibly expensive. And so my work looks to try and use generative tools to try and perform this mapping for us, to try and perform the bidirectional translation to text and also to linked data. But as I have talked to colleagues within the domain, hardware is a very significant limitation in many institutions, and so generative tools which rely on powerful graphics cards or powerful machines are out of reach for many people. Full fine-tuning of a large model is not just actually loading the model, it's 10 times that to load the optimizer as well. And so we either need to shrink the models that we use, or we need to find more parameter efficient and more data efficient techniques that we can use to actually perform these complex tasks that will save a lot of time in institutions. So I don't have a lot of time to go over the training mechanism. I want to focus on the data. If you're interested, please come and find me afterwards. But the translation method that I am taking is from neural machine translation. And in particular, it's unsupervised neural machine translation. So in the first instance, or actually, I guess I'll talk about this diagram on the side here. To reduce the amount that we're actually training, we can simulate having two models, one learning the text to linked data and one learning the linked data to text translations, by combining them into one base model, and then we attach two small networks to the side, which we switch, simulating this process here. And what this basically does is mean that we can fit a much larger, more capable model while training fewer parameters. And this deals with many different problems due to environmental concerns and training times and amounts of data that are required. But to summarize this training mechanism, in the first instance, we pass a real sample into one of the models, and we generate a fake version of what the other model expects as input. We pass it into the other model. We then get that model to try and recreate the original real sample that we put in. And now we have the traditional machine learning approach that we need, which is we have a real sample and a predicted sample. We can calculate a loss, and we can now update this model. And we switch between the two cycles. In the first instance, we might pass in real text, and in the second instance, we might pass in real linked data. And over time, these two models improve the quality of the other model so that we don't need to have this expensive aligned data. We can use larger, more freely or widely available sources of just text and linked data separately. And something which I always forget to mention is that I'm releasing this training mechanism as a Python library. It's nearing the first release. So I will have a QR code at the end for those that are interested. But what I think is more interesting to the community here is the data. As I mentioned in the title, and here I'm using linked art. And as convincing as Rob is, there are practical reasons for why I'm using this data. So JSON, and JSON LD in this case, is widely recognized by language models. It's seen particularly in coding models, so it's very familiar with the structure and the syntax. The compacted form of linked art also removes a lot of URIs, which deals with a lot of the issues of hallucination that we might deal with. I'm working at a gallery, so linked art is very relevant to what I'm working on. So skipping to the other side, we are using a large corpus of text documents, primarily Wikipedia abstracts related to painting or objects and people. But the main point of interest, I think, in this training mechanism is this combined data set in the middle. Because we aren't dealing with mapped data, we actually have to now find data which overlaps to make sure that we can align these two spaces. You can't learn to translate from one language to another if you don't have any words that mean the same thing between the two languages, and the same is within this data. And so a lot of the effort that goes into trying to work on this approach is about increasing the overlap between these two domains so that we can improve the quality and alignment speed of this training mechanism. So for the linked data, we're using Lux, which I believe there's a presentation at the start of the next slot. And for the text records, we're using web texts and Wikipedia abstracts, as I mentioned, and ULAN artist bios. And the overlap is where we have a Lux entity that also has a corresponding Wikipedia abstract. But there are some difficult challenges that we have to face. This training mechanism was primarily designed for one-to-one mappings. But as we can see, linked data is distributed over many texts. So we see this is now a one-to-many mapping. And why this is incredibly important is because we have a very complete, information-dense linked art record. And if we are only generating one text, what we have is now a very sparse and information-poor record. So now, when we try to teach the model to generate text, it's going to learn to forget a lot of the information. It's not going to transcribe everything. But equally, in the other way, we have an even greater problem. If we have an information-sparse text and we want to try and create an incredibly information-rich linked data record, it's going to start hallucinating information because it's learned that it has to include a lot of information for it to be appropriate. So what we can do is we can take our full linked data record and we can start to remove structures from this in an intelligent manner. And specifically, it seems counterintuitive to start making our information more poor, but what we can actually do is generate multiple samples from an individual entity record, and then we actually improve the amount of data that we have. By sacrificing a small amount of quality, we now actually create a greater alignment and we increase the dataset size that we're working with. The obvious thing is we still need some way of identifying the records. That's the minimum requirement. But as I alluded to as well, text is also distributed among many records. So we're now dealing with a many-to-many mapping, which is not what this was designed for, but language models are very good at actually managing this translation for us. But to make this a many-to-many representation when we're actually performing the training, we can now stack multiple entities together, which JSON LD isn't really meant to do, but language models don't care if we're treating them as text anyway. But the main thing is that we want to maintain some single entities so that the model isn't encouraged to start generating information about entities that don't exist in the text because it's expecting to see more than one entity. The third main challenge now, and this is fairly critical now that we're talking about putting multiple samples into each context, is context length. And from looking at linked art samples, let's say we're working with Llama, the input size is 8,096 tokens. The average size that I found in the data set that I received from Rob is 13,000 tokens, and the longest sample was 50,000. So we have to do quite a lot of work to reduce the size of these to actually make them manageable by the model. and I'm going to have to speed up through the rest of this because I've got 40 seconds. So one of the main things that we can do is we can remove appellations. We can reintroduce those later because many of these are linked to external sources. And many of the equivalent fields can be reintroduced, as I said. But equally, we can change our mechanism for stacking entities so that we randomly generate a maximum number of entities to include, and then choose whichever comes first, the maximum model input size or the maximum number of entities. I didn't realize I had those coming on one by one, but so I did have more to say about putting these models into action. If you'd like to hear more about that, I would be willing for you to come and ask questions about it at the end. But if you are interested in using this training mechanism, I have a QR code for accessing my GitHub. The pre-release will be out at some point in the near future when I can resolve all of the underlying issues with it still. So thank you very much.
Thank you very much, William. And
Thank you very much.
Actually, if I could invite you and the rest of the speakers from this morning to come up to the front and stand between here and the QR code, nowhere else, so that people out there...
Yeah, don't block the QR code, it's great advertising.
The QR code, for God's sake.
So we heard a lot of interesting talks this morning, ideas, methods, projects. I open the floor to the public if you would like to ask a question of any or all of our speakers. We have a question from Antoine.
Antoine, I hope you don't ask me.
Hi, Antoine from Europeana. I have a question. I don't know precisely for whom it is. Maybe several of you can address it. That would be great. It's about the collection level data. So there have been presentations about a lot of great work for describing individual objects within the collections. Some mentions, I think it was in Lucía's presentation about collection level information, so data about the entire set of objects. And I was wondering, whether this is an aspect that you have addressed in the works that you've presented. So either like an intellectual collection or a data set level information. And I don't want to blame anyone. I'm part of an organization that has gathered information about individual objects for 10 years without asking any dataset level information. So I know this is a problem. But it makes me curious whether you've dealt with it in your work.
Okay, thank you. Yes, actually, with Edurne, we are working about the collection information, the metadata of collections, not about the objects. We work in FUAPO, we work actually with the objects, but with Edurne, we are working in the census of collections. So we have, she actually has the structure about the metadata about the collections and the collectors, all the history about our collections at the university.
Thank you.
Thank you.
Are there any other questions people would like to pose? Please.
Hi, I'm Helene from the Utrecht Archives. I have a question for Liam. I was wondering, you were explaining that you kind of need more space for the input, but you're working with Llama, so that's smaller than some of the commercial options that you have. Did you try for this case also using the commercial ones where you can get all the information into?
Yeah, I think maybe I missed some of my motivations for the project as well. So one of the major limitations that I've imposed on this project is that I don't want to use those commercial tools, mostly from the perspective of many institutions cannot share the data due to copyright. They cannot actually give the data to these third-party institutions, so they're not an option. I can't train those models either, is the main limitation. And as well, many people are unwilling to use them because companies claim that they don't use your data as training data, and we have to take their word for it. But these models are very capable at doing this translation already. I know of another project in the UK that's looking at using ChatGPT to basically generate CIDOC CRM from text as well, and it does quite a good job, but not having access to the model yourself, not having access to all of the knowledge of how your data is being used is one of the main reasons for why I'm trying to make this so that you can actually inspect everything from the inside.
Thank you. And then on the bright side, I can imagine that within 1 year you also have it available in Llama, hopefully.
Well, I hope the library will keep progressing over time.
It's bright down here. Are there other questions?
Thank you. I have a question for Stephen, because there is these two very important words in your presentation about evidence and interpretation. And I don't know how it works in archaeology, but in other social sciences like sociology and anthropology, it's always a big diffuse discussion between what is evidence and what is interpretation. And also the museum documentation definition had a thought about that in the workshop on Monday, what is evidence, and we stopped there for a while. So I would like to know, what have you discussed about the diffuse difference, because we can have the extremes of what is evidence and what is interpretation, but the line between them is very fine, and how this position of working with CRM raises, and if it has raised the discussion of where to place the fine line between them.
Yes, there's always a real problem between objectivity and subjectivity in any of these data sets. In the CRM Archeo, we've drawn the line at physical versus saying what it means in terms of stratigraphic relationships. So there's quite a few recording practices in archaeology where the physical set of relationships are recorded, and from that you generate your interpretation of the stratigraphic sequence. And that's basically the divide that's been chosen within the modelling to represent that difference between the physical and the intellectual process of putting something on top of it. And this is very much the way that we feel that reinterpretation of stratigraphy happens. So the evidence of actually seeing sites be reinterpreted is very much that you can't change the physical observations that you made. This piece of earth touched this piece of earth, or it didn't. But the meaning of that, the sequencing, particularly where you're applying the interpretation of a record to understand the interfaces which haven't been recorded in many recording practices, is one of the things that we can draw the line at, if that makes sense.
Yes. Thanks, Steve. Well, this has been an excellent set of papers, really interesting, and I think there's like all sorts of cross connections, and if we didn't have a sign here that was bright red that was telling us our time was up, we would explore this in greater depth. However, it does, and so first of all, I'd like to invite everyone to give a round of applause again to everybody who presented this morning.